Morning, everyone. We've got a warm up here. Two questions. Basically, they're the same thing, but it's just to practice what we did from last week or 2 days ago. Go ahead and hit pause, and then we'll work through the following items. All right. So now that you had a chance to try this, let's go through and answer a couple questions. So right away, we notice that this is in the form of y equals a times x minus p, times x minus q. So this is our intercept form. Which means we can set each one of these parentheses equal to 0 and solve, but you could probably do that in your head. You can see that it's opposite of p, opposite of q. If you don't recognize that, we're basically saying, well, what if y is equal to 0? If y is equal to 0, then each factor would be equal to its own 0, just like we talked about last week. And that gives me my two zeros. Right? I got a spot at 1, 0 and 5, 0. So that gives me the location of each 0. So I plot those on the graph first. Go over 1 up 0, 2, 3, 4, 5. And then I'm always a big fan of labeling them just so the person reading your graph knows. Now you'll notice one thing here. The a value isn't present. And in that case, we can always put a 1. But I like to think of that as a +1, which tells me we know my graph is going to be opening upward. Right? Now, if I know the zeros are at 1 and 5, the axis of symmetry has to be the number right in between those. So you could count on your graph, or you could take the average of them. 5 plus 1 divided by 2 is 6 over 2, or 3. So that tells me my axis of symmetry is 3. So I'll go over 1, 2, 3. And you can plot that middle point. And then we're going to label it axis of symmetry, x is equal to 3. Now, the vertex is the x value of the axis of symmetry. And then all we're going to do to find the y value, if you know a point, you're just going to plug it in. So if I take that equation and I plug in 3 each spot where there's an x, and then we're going to simplify. I get 2 times -2, or -4. And there's the vertex. I'm going to go over 1, 2, 3, down 1, 2, 3, 4. And that's all I need. We know, because this is going to be opening upward, that there is a minimum, and that minimum value is at -4. So the only way I could make this even a little bit more accurate, I shouldn't say the only way, but a way to make this more accurate is to find the y-intercept, right? And that's whenever x is 0. So what do I get if I plug 0 in here and here? And you could show your work, or you could do that in your head. But if I do 0 minus 1 and 0 minus 5 and multiply those together, I get -1 times -5, or +5. And there is the y-intercept. So I'd go over 0, up 1, 2, 3, 4, 5. And notice the y-intercept is 3 units away from the axis of symmetry, so I could take this point, reflect it over, and go 3 points to the other side, and that just gives me more points to graph my parabola. And then once you have it, you're going to draw that graph through those points, make it a nice U-shaped curve, don't make it a V. That's not perfect, but there you go. All right, and then the other test is, what if I take this exact same example and I want to convert? What do? We FOIL. Now you could FOIL, or you could use the box method. But if I do x times x, I get x squared. X times -5, Negative 1 times x, negative 1 times 5. And there is my standard form. Well, one little thing here just to show you is what did we do to go from standard form to, intercept form to standard form? Was I FOILed or I expanded this out? Well, what if I was in standard form and I wanted to go the other way? How would I undo a FOIL or a multiplication? You would factor, just the way you did before. So if I tried to factor this using the box with the circle in a method or any other method that you've learned, when you factor this, you'll end up right back where you started. And notice that's just kind of a inverse relationship. Expanding, FOILing will undo factoring and vice versa. So what does that mean? That means that if you would like, you can float between graphing via standard form or graphing via intercept form. If you don't like one of the forms, you can go the other way. However, sometimes an object is not factorable, and we saw that before, and that's where we get a little stuck. All right, here's the quote for today. Life is a math equation. In order to gain the most, you have to know how to convert negatives into positives. So let's look at how do we graph in standard form. I'm going to lead you through kind of an example here. There are formulas for this, but I want to show you, we already know a lot of this to kind of move along. So what I want to do is if I want to create a graph, I want to find the zeros. Well, in zeros, we would either factor if possible, or we would use the quadratic formula. Now in this case, factoring is not possible because there are no factors of -3 that add up to give me 4. So factoring doesn't work in this case, which means I'm going to have to do the quadratic formula. And this is just a real quick review. I know that A value is 1, B is 4, C is -3. So I'll just do the quadratic formula. The opposite of B is -4. B squared minus 4 times A times C all over 2A. So let's see. So B squared minus 4 times A times C. 3, -3, all over 2A. And then we'll simplify. I don't have a ton of room, so I know that 4 squared is 16. And then I know that, let's just plug it in. I get 16, and then -4 times 1 times -3 is, remember that's a -3 there. It doesn't look like it. There you go. That's going to end up being a positive 12 all over 2. And then we can simplify. Now, in this case, we broke down the radical, but radicals don't give me a great idea of what this graph is going to look like. So I'm actually going to do this in my calculator. And I'm going to figure out what is the answer when we use the plus, and what's the answer when we do subtraction. So I get 0.646 if I round that to 3 decimal spots. And then on the bottom, the -4 minus the square root of 28 divided by 2. And I get -4.646. And that's not great, right? I don't love those, but that's what happens. Numbers aren't always perfect, but I can plot them, right? Those are my zeros. So I know that I would go over 0.6, which is right about there. And then the other one is going over negative 4.646. So we're going to estimate 1, 2, 3, 4. That might put us right there. So I've got my two zeros. Now, we saw that. That's like your P and your Q, right? Even though this was not written in perfect form, this was written in standard form, that value was just like my P and my Q. Those are the X values, and I know that the axis of symmetry lies perfectly in between them. So what was our rule for the axis of symmetry? It was the average of your zeros. Do your P plus your Q divided by 2. So what I'm going to do is I'm going to take 0.646 plus negative 4.646, and I'll divide that by 2, and that will give me the axis of symmetry, the line right in the middle of those two. Well, the nice thing is this actually ends up being semi-friendly. The axis of symmetry is negative 2. And if you graph that, I go right over to negative 2, that should be perfectly in the middle of those 2 points. So I'll label that axis of symmetry, or we can call it line of symmetry, same thing. But now that I have that line of symmetry, the vertex, use the line of symmetry to find the y value of the vertex. Well, that negative 2 is the x value of my vertex, which means I just got to find the y value. And anytime you want to find the y value, you take the original equation and plug in the x that you know. So I'll plug in negative 2 back into the original equation here. And we end up with a positive 4, negative 8, and a negative 3. Which ends up giving us negative 7. And there's my vertex. Go over negative 2, down 7. 1, 2, 3, 4, 5, 6, 7. And this should make sense. I didn't point this out right away, but notice how the A values are positive. That means the graph is going to open upward. So I know that having a vertex below the 2 zeros is putting me in the right spot. So technically, I do have enough to graph a nice parabola, but let's look at the y-intercept. Maybe the y-intercept is going to help us. The y-intercept is always going to be when x is 0. So notice this one you could do in your head. If I put a 0 here and a 0 here, you get 0 plus 0 minus 3. The only value that comes out of that is negative 3 then. So I can graph my y-intercept at 0, negative 3. But that's 2 units away from the axis of symmetry. So let's reflect it over and just get another point to make this graph a little more accurate. And there you go. Whoops, I didn't put this down. 0, negative 3. We know that this is a minimum value because it's the lowest point on the graph at negative 7. And then do your best to draw a nice smooth curve that is hopefully as U-shaped as possible. That's a little bad, but I think you guys will forgive me. So you'll notice it's not really anything brand new. If you know your zeros, you can find the axis of symmetry pretty quickly. All right, so feel free to pause this, write down anything you need to. Now I will admit, that was a lot of work, right? But it's building off of the knowledge that we already know. So is there a faster way to do this? Kind of. The downfall is it requires you to memorize a couple of formulas. So I'll show that to you. You may like this, you may not. But if you have a quadratic function in standard form where you can identify what A, B, and C are, Then you can find the axis of symmetry or the line of symmetry by doing this formula. The opposite of b divided by 2a. And that will give you the x value of your vertex. So as soon as you find the axis of symmetry, you know what this x is. Right? It's the same thing, opposite b over 2a. So that's your axis of symmetry, and then all you do is take whatever this x is, plug it into the original equation, so whatever answer you got here, plug it in for x, and your output will be the y value. And that automatically gives you the line of symmetry and vertex. And then you really just need your y-intercept, which no matter what form we're in, any of the three forms we learned, it's always letting the x value equals 0. So what if I plugged in 0 here and here? Notice it doesn't matter what a and b are. The only thing that's left over is the c value. So there's my y-intercept. And then what tells us if the graph opens up or down? If the graph opens upward, notice it has a low spot, so that's my minimum. And that's if a is positive. Right? Well, what if it's a maximum? Then the graph opens downward, and if the graph opens downward, then you know for sure that your a value had to be negative. Okay? So just by looking at the a value, you know right away before you do anything if your graph should open up or should open down, and if it's a max or a min that occurs. All right? So hit pause, record anything you need to, but let's try using these formulas to graph. Okay. So here's what we got. We got another standard form equation. Now right away, I hope you look at this equation and you say, all right, it is written in the form y equals ax squared plus bx plus c. And if you want, just like we did with the quadratic formula, you can identify what a, b, and c are. Well, I hope the first thing you're looking at is the a value. A is -1. So it's negative, which we know it's going to open downward. If it opens down, then you automatically know that there has to be a maximum value. Okay? So now I could try the quadratic formula, and I could find the zeros, and I could do the same work we just did, which I think is kind of fun, but it's a lot of work. So what about the axis of symmetry? We had a formula. X is equal to opposite b over 2a. That's the formula for the axis of symmetry. We know what b is. We know what a is. So that'll quickly give me that axis of symmetry. So if I do opposite of b, all right, b is 6. So opposite of 6 is -6 over 2 times a. That gives me -6 over -2 or +3. So I know the axis of symmetry is +3. Well, as soon as I know that axis of symmetry, then I can go to the vertex. And I know that the x coordinate is 3. Well, what we need then is we need the y coordinate. And anytime you're looking for just a single value, all you're going to do is take the given equation and you're going to plug in x equals 3. Now we do have to be careful because the negative's on the outside, so 3 squared is 9, and the opposite of that is -9. 3 times 6 is 18, minus 8. And when you combine all those, you end up with the y value, which is 1. There's my vertex. And we already know that this is a maximum point, even without graphing it. The A value told me the max. And now we actually know what the maximum value is too, right? It's the maximum value of what's the lowest output we're going to hit, or highest output, because it's a max. It's 1. It's the Y value of your vertex. Okay? The 3 is where it occurs. The 1 is the actual value of it. So I might stop right here, and let's graph what we know. I know that x equals 3. 1, 2, 3. That's my axis of symmetry. And then I know that when I go over 3 up 1, that's my vertex. And I really just need one other point. Now, is it X-intercept that I need? Or is it the Y-intercept? And to be honest, I would just go right for the Y-intercept. If it's helpful, let's use it. So the Y-intercept is whenever x is equal to 0. So what if I plug 0 in here and 0 in here? The only thing that's left over is -8. I'll go over 0 down 1, 2, 3, 4, 5, 6, 7, 8. And you can see once you have that y-intercept, you know you are 3 units away from the axis of symmetry. So let's reflect this point over to the right and go 3 more units in the other direction. And that just gives me that extra point that I need. Now, you have options. You could draw this parabola and just kind of mark it. You have 3 points to make your parabola. Or you could pick other points. You could test what happens when x is equal to 2. What if I plug 2 in? That will give me another point. What if I plug 1 in? That would give me another point. And eventually we'll teach you how to do this on your calculator. The other option, and this is a lot of work, but I'm not going to require that you do this. But what about the X-intercepts? Now, you could try the quadratic formula here. And I'm just going to set that up so you can see how it works. This might even be factorable. So you could try to factor this if you want. I actually think it is factorable. So you could try that as well. There's a lot of options you have. But I'm going to just do the quadratic formula really quick. I'm going to assume that you guys are pretty comfortable with that. So I'll end up with 36 minus 32 over -2. Then I actually have a very friendly 36 minus 32 is 4. Well, that actually gives me a nice friendly answer. Square root of 4 is 2. And then I can write both answers as -6 plus 2 over 2 and -6 minus 2 over 2, which is -4 over 2 or -2. And x is equal to -8 over 2, which is -4. Now, because I got 2 really nice answers, that actually tells me that this is definitely factorable. Oops, sorry. Let's see. I made one tiny, of course, I made a mistake. That's a -2 down there. I forgot the negative. So that's actually going to make this a +2 and this a +4. So I almost missed that. I was trying to go too fast. But I get 2 answers. I get my X-intercepts at 2 and at 4. And again, you could factor this with the box method, you get those answers again. But now I can actually do a really nice graph. I can go over 2 and have a 0. I can go over 1, 2, 3, 4 and have the other 0. And notice I've got my really nice graph, 5 points. There we go. So that's how you can graph using the formulas, which just helps you a little bit. The X-intercepts aren't necessary, but they are friendly, or it makes your graph look better. So if you want to take the time to factor or do quadratic formula, I would recommend it, but it is not required. Let's look at another one here. And what you should be doing here is just pausing your computer or pause the video and try this on your own. So I'm going to actually do that as well and set it up, and then we'll reveal the answers. So I calculated the line of symmetry or axis of symmetry first. I took the opposite of b, so the opposite of b is 3, all over 2a, so 2 times 2 gives me 3/4. And there it is, a very sloppy, but axis of symmetry is 3/4. Now, if I know the vertex is when I plug 3/4 into the expression, into the original problem. So I'm going to pause the video and I'll do that. All right, so let's look at how fun that was. When you take the line of symmetry, 3/4, and that's my x value, and then I plug that back into the original function. If you follow this without a calculator, we're going to square the top and square the bottom, so we get 9/16. And then I think of this as 2/1. And then here we get 3/4 times -3, so I get -3 times 3 is -9, 1 times 4 is 4, plus 4. And then I can multiply across. 2 times 9 is 18, 1 times 6 is 16, so I'm trying to get the same denominator here. So I get 18/16, and then I'm going to subtract 9/4. Well, what I would do is just convert this to 16ths. So I get times the top and bottom by 4, so I get 36/16. And then I'm going to take this, think of that as 4/1. If I times that by 16, top and bottom, I can turn that into 64/16. And that way they all have the same denominator. You could actually kind of reduce this to make it even easier. That's just the route I took. And I end up with 46/16, which reduces down to 23/8, or since we're graphing this, you could even plug this into your calculator and get 2.875. Now, I wanted to do a problem like this to show you that it's not always going to be really pretty numbers, right? You're going to have decimals or you're going to have fractions, and that's fine. That's part of life. So what do? Well, I got to graph this. So I'm going to go over 3/4, and then I got to go up 2.875. So again, I have to estimate this, but just to make sure the person reading it isn't left to guess, that's why I write what I have right here, my decimal. And it might even be better to write it as 23/8 here, so then you have a fraction and fraction, but there it is. All right, so then the next point is the y-intercept. Well, that's pretty quick. If I plug in 0 here and here, the only thing that's left over is 4. So I'll go over 0, up 1, 2, 3, 4. Now here's where you have to be careful. We're 3/4 of a way from the axis of symmetry, right? Because this is going over 3/4. So what if I go 3/4 in the other direction? That's going to put me right here at 1.5. Now you notice the a value is positive, which means I'm going to open upward. And there's my parabola, which kind of shows that there are no real zeros. Now, to make a connection to what we've learned in the past, what if I tried to find those zeros? Just like we did before. And you don't have to write this. I'm going to actually pause the video and just show. We know this is not factorable because I don't get any zeros that are real numbers. which means they're not real, but they are imaginary. So I'm just going to show you what that looks like. I'll do the quadratic formula here and just pause the video and then show you my work when I'm done. Okay, so without going in great detail, if I took A, B, and C and I plugged them into the quadratic formula and I did my simplifying, you can pause the video and check. I'm going to end up with this discriminant, the number underneath the radical. Notice that's a negative 23, but that negative is pulled out and we treat that as I, which tells me I have two imaginary solutions, which is why I have no real zeros. They don't cross the x-axis. I think that's just important for you guys to make the connection that if your function does not cross the x-axis, it means that only imaginary answers are possible. Kind of a cool connection to what we've done in the past. All right, last one that we have here, and this is a fun one, right? So what happens, we're not ever really going to get super friendly answers, right? We're going to get, sometimes we have to deal with decimals, and sometimes our answers are decimals or fractions. The nice thing is the work that we do is all the same. So first thing we're going to look at is what is the A value? What's the B value? And what's the C? And then we're just going to do what we need to do to get this done. So axis of symmetry is opposite of B over 2A. Well, B is negative 8 over 5, so the opposite of B is positive 8/5. And then I'm going to take and times by A, which is negative 1/5. Now notice that's times by 2, so I'm going to make this 2 over 1 when I multiply fractions. So I got 8/5 on top, and then when I multiply straight across, I get negative 2 over 5. Actually, I'll do that in a separate color, just so you can see what step we're going to work with next. Now, we don't love division of fractions, right? I actually like to rewrite this and kind of think of it as take the numerator, and instead of dividing by a fraction, we're going to multiply by the reciprocal. And as non-friendly as these numbers are, watch what happens when we actually multiply. This turns into 8/5 times the reciprocal of the denominator, so 5 halves, negative 5 halves. And then I've got a 5 on top and bottom that are going to reduce out. And what's left over is 8 over negative 2. But 8 over negative 2 is the same as negative 4. So that actually is kind of helpful for a line of symmetry. So let's go ahead and graph that first. Go over negative 4. And there's my axis of symmetry. And as we know, the vertex, you just take the x value and plug it in. So I got to plug in a negative 4 here and here and then simplify. I'm going to do this without a calculator, but if this is a little intimidating, I won't be too heartbroken if you grab your calculator. Just make sure when you use your calculator that you're using parentheses correctly. All right, so I'll pause the video and work through this. Okay, so I went through and just plugged in negative 4. I squared negative 4 to get 16, and then multiplied fractions. So I thought of this as 16 over 1. When I multiply fractions, you multiply straight across. You get negative 16/15 for this part. Here, I have negative 8 times negative 4, so it's a positive 32. And I've got 5 times 1, so 32/5, and then minus 1/5. And now, since they all have the same denominator, 16 plus 32 minus 1 is 15. Whoops, And this is 15 over 5. 15 over 5 is 3. So I now know my vertex, which is negative 4, 3. So I'll go over negative 4, up 1, 2, 3. And notice my A value is negative, so I know my graph is going to open downward. I just need one other really nice point to make this graph. So I'm going to do the Y-intercept, which is always 0. So if I plug in 0 here, the only thing that's left over is negative 1/5. So I'm going to go over 0, down 1/5, which I'm just going to have to estimate. And I might tell the reader, there's my point. Now, notice how far this is away from the axis of symmetry. 1, 2, 3, 4. If I reflect it, 1, 2, 3, 4, I have that same point. And wow, that is not a great parabola, but I think you guys get the idea. Is there a max or a min? Since the A value is negative, we know it's opening downward, there's a minimum. In this case, you could do the quadratic formula and get your zeros. I'm thinking we're running out of time, and I really don't want to do all that work, getting a little lazy, but we will show you on our next class, how can we use our calculator to find the vertex, the zeros, the y-intercept? How can we do all this using a calculator? So, your homework tonight, same thing, you must use graph paper just like you did in the last assignment. You're going to be asked to graph 21, 24, 27, and 30. Please keep in mind some of those are not super friendly graphs, kind of like the ones we did in class. And then the last two, you're just telling us if there's a max or a min value. So my hint to you is to use the equation, well, tell whether there's a max or a min. You know right away just by looking at the y value what those are. But then it says find the min or max. And that's where you have to use the equation. You don't need to graph these two because you can just find the vertex. And if you know the vertex, then you know the max or the min. Kind of like we did here. I did all my work and I found the vertex. And I know that there was a maximum because the A value is negative, so it's opening downward. And then what is the maximum? Well, the maximum is always the Y value. So we could say there's a max of negative 1/5, because whatever the Y value is, that's the, I'm sorry, I went to the wrong one, 3. Right? So if I look up here, what's the highest value that this graph reaches? The maximum value is y equals 3. Okay? So you don't really have to do much work for the last two problems. That's your homework tonight. Make sure you submit it to Schoology when you're done. Have a great day.